If we look at problem number 1 on the worksheet, we're asked to identify the type of reaction and then balance. So the problem that we're given is Mg plus O2 yields MgO. So for the first step of our problem, we need to identify what type of reaction this is. And at the top of your worksheet, there's actually a little key there to help you narrow down what type of reaction this is. So we're just going to look at the reaction definitions and figure out which one this best fits into. So we'll start at the top. A synthesis reaction is 2 or more substances combining to form one new substance. So if we look at our problem, we have Mg plus O2 yields MgO. Now if you notice, we can just stop right there because that's exactly what we have. We have 2 substances, Mg and O2, reacting to form one new single substance, MgO. So on our answer line, we can go ahead and write that this is a synthesis reaction. Now for step number 2, we're asked to figure out if this equation is balanced, and if it's not, then we need to balance it. So you might find it helpful for this part of the problem to use your notes from yesterday and look at the steps for balancing chemical equations. The first step is to make a list of how many atoms appear on each side of the equation. So to do this, the best way to keep track of your reactant side and your product side is just to go ahead and draw a line separating your reactants from your products. And now we can make our list. So on the reactant side, we have 1 atom of magnesium, and we have 2 atoms of oxygen. On our product side, we also only have 1 atom of magnesium and only 1 atom of oxygen. And so we want to check and see if this equation is balanced. Our magnesiums have the same number, so those are okay, but our oxygens do not. On our reactant side, we have 2 oxygens, and on the product side, we have 1. So we need to balance this equation so that it follows the law of conservation of mass. So step number 2 in balancing is to look for an element that is only in 1 chemical on each side of the equation. We have that already, so we can skip to step number 3. Step number 3 is to identify the chemical species on the side which doesn't have enough atoms and multiply that one by the number required to bring it up so that they're equal on the other side. So what that means is we need to multiply this oxygen on the product side by some number in order to make it equal to the number 2, which we have on the reactant side. Now remember, the only way you can change a chemical formula is by putting a coefficient. We cannot add subscripts. So if we need to have 2 oxygens and we only have 1, we're going to put a 2 in front of our MgO. And what that's going to do is multiply everything that it's in front of by 2. So this will change our magnesiums to 2 and our oxygens to 2. So now our oxygens are balanced, so we can put a check by those. But now, in changing our oxygen, we actually changed our magnesium number as well. So now our magnesiums are no longer balanced. We have 1 magnesium on the reactant side and 2 on the product side. So what we're going to do is go back to the reactant side and simply put a 2 in front of magnesium. And what that's going to do is multiply magnesium by 2. And so now we have 2 atoms of magnesium on the reactant side and 2 on the product side. So now magnesium is balanced. And just to double check, oxygen, we still have 2 on both sides. So oxygen is balanced. And this is our final answer for our balanced chemical equation. Our coefficients are 2, 1, which you don't have to put, but you can if it helps you, and 2.